All right, so I would write this in your additional notes. So this is just one last example of the slope field / differential equations, separable ones. Okay, so the slope fields, hopefully you guys did for your homework already. They're pretty easy. So this one, you have 1 plus y all over x is the slope at each point, and you have the different points listed. So you can do your table if you want, or you can try to do it in your head. Sometimes it's kind of hard to do in your head. So let's do x, y, and then the slope dy over dx. Nice straight lines. So we have, this is -2, 0. So if you're doing 1 plus y over x, that would be 1 plus 0 over -2, so you get -1/2. So at -2, you're going to have -1/2 as your slope, something like that. You also have -1, 0. So that's 1 over -1, so it's -1, so it's a little bit more steep, and it's negative. You have 1, 0, so now it's positive. And 1, 2, so it's positive and 1/2. Okay, then we have our 2 other points, or 4 other points, I guess. 2 on top, 2 on the bottom. So we have -1, 1. So -1, 1 gives me 2 on top, -1 on the bottom, so -2. So it's even more steep. Hi. Yeah. Yeah, can.
Is that okay? Is this the time I can
Yeah,
do that?
sure. All right, and then -1, -1. So you have 0 on top, so 0 is your slope. See how this other one's also going to be 0 over here, because y is 0, or y is -1. And then the last one is 1, 1. So it's 2 over 1, so positive 2. So you get that. Okay, so now for the actual separable differential equation. So we're going to separate our variables. So dx is going to go over here, and I'd have 1 over x with it. I need to divide by 1 plus y, right, to get rid of the 1 plus y on the other side. So I have 1 over 1 plus y dy. And I think that's what Victoria was asking me at the beginning. She didn't know how to integrate 1 plus y like that. All right, there's something that we're going to do later that's called the U substitution, which is in section 7.2. Maybe I shouldn't have combined 7.1 and 7.4. Maybe that's leading some of these problems. But this one's really not bad. I mean, if you think of 1 over y, you guys know how to integrate that, right? It would be what? Natural log of the absolute value of y. So this is going to be natural log of the absolute value of 1 plus y. Because think about it. If you take the derivative of that, so the derivative of this would be 1 over 1 plus y times 1, right? That's what we had. So think of, you know, taking the derivative of your answer and make sure that it's the same. Okay, and then the other one is natural log of absolute value of x. Okay, then we solve. Okay, so we want to solve for y, so I'm going to do e to both sides. So I'm going to have e to the natural log of 1 plus y equals e to the natural log of absolute value of x. So you get absolute value of x equals absolute value of 1 plus y. Okay, when you remove the absolute values, you have to write plus or minus. So 1 plus y equals plus or minus x.
Isn't it x plus c?
X plus, oh yes, thank you. I forgot my c. I would fail. Oh, now it's up there, isn't it? So let's find c up here then. So you don't have to erase, but I just need more room. So if I'm going to find c, I'm going to plug in my initial condition -1, 1. So I have natural log of absolute value of -1 equals natural log of 1 plus 1. So you get natural log of 2 equals natural log of absolute value of -1 is natural log of 1, which is 0. So equals c.
So you plug it into your first equation then?
I always do. You can plug it into the equation you get once you solve for y. That's fine, but it's just a little bit messier because your c is changing along the way. Yes?
What if you only have natural log on one side? Would you still do e?
Like in your homework, if you only had natural log on one side?
No, we don't.
Yeah, if you had like natural log of something with y in it,
Yeah. Yeah,
and then something with x over here, yeah, you'd still have to, in order to solve for y, you'd have to do e raised to both sides.
both sides.
Uh-huh. All right, so we have natural log of 2 is my c value, so I have natural log of 1 plus y equals natural log of the absolute value of x plus natural log of 2. And you can do e raised to both sides. And this is what we were talking about yesterday when we have, like if I had x squared times x to the 5th, that's x to the 2 plus 5. Right, so we're going to go from this step back to that. So I'm going to write this as e to the natural log of absolute value of x times e to the natural log of 2. You know what I'm saying? All right, so I get e to the natural log of 1 plus y. All right, now e to the natural logs cancel, right? So you really have 2 absolute value of x equals absolute value 1 plus y. And I said if you want to drop absolute values, you can plus or minus. So you write 1 plus y equals plus or minus 2x. So in other words, y equals plus or minus 2x minus 1. Okay, but on these initial value problems, you should not have plus or minus. So think about that. How can I decide if it's plus or if it's minus? Plug in your initial value. So when you plug in your initial value, you get 2 times negative 1 minus 1. It can't be that, right? So it needs to be negative 2 times negative 1. So that'd be 2 minus 1, and that's how you get the 1. So it has to be the negative 2. So y is negative 2x minus 1. Does that make sense? Because you have to have negative 1, 1 out with your initial value. You have to have this point, negative 1, 1.
So you just go with the same sign as that when you plug it in?
No, so you need to decide if it's plus or minus. So you have 2 choices. So your first choice is y equals 2x minus 1, and the second choice is y equals negative 2x minus 1. And so when I plugged in negative 1 for my x, I said, oh, it can't be this one because that's negative 3. So then I knew that it had to be negative 2. All right, and then the very last step, if you guys ever have a natural log in your problem, usually it will kind of give you a clue. It will say something like, state the domain. So go back and look. If you had done like a, you know how like f of negative 1 is 1, so f of negative 1 is 1. You're following this curve. That helps you out. So seeing the slope fields, I think, helps you out. Oh, wait. Then there's this weird 0. I don't know what's going on. It's not 0 here. I think it does something like that. We'll have to put it on Graphler and see for sure. Basically, like we know we're on the left branch. It's undefined on this line because x is never equal to 0. If x was equal to 0, your slope is undefined, right? So you're never going to cross that line. So with the natural log problems, you need to think about what branch you're on. Burke, you paying attention? All right, so you have 2 pieces of the domain. Since we had natural log of absolute value of x, we need a continuous domain. It can't be negative infinity to infinity because we have a discontinuity at 0. So we have to pick one of those 2 branches. So we're going to either pick x is greater than 0 or x is less than 0. Does that make sense? So we have 2 choices, x is greater than 0 or x is less than 0. So like I said, if you think about drawing your branch in, it makes complete sense that it's going to be x is less than 0. But if you didn't draw that in, go back to your original, and you had f of negative 1 equals 1, well, that means that negative 1 needs to be in your domain. Makes sense? So you have to have this for your domain. X is less than 0. Okay, so the 2 answers, the 2 pieces of the answer they'd look for are these 2 pieces. Okay, so this was an actual free response question. So I wanted to show you how they score on these 2. So this was from 2006. And the first part said draw the slope field. So see how we have the same slope field? We had that picture. You got 2 points for that. And what they're checking for is the sign of the slope at each point, so that it was positive or negative, and the steepness of the slope in rows and columns. So just that this one is steeper than this one, which is steeper than that one. Kind of what they're saying, okay? All right, and then the next thing was find the particular solution. So find the solution with this initial condition and state its domain. So see how they gave you that clue that this is a domain problem? So state its domain. All right, so they go through all the steps, and you could write it 2 different ways. You could say y equals 2 times the absolute value of x minus 1, or y equals negative 2x minus 1, and the domain is x is less than 0. Now the scoring on these is very, very important. So you see how this whole thing, part B, is worth 7 points. You get 6 points for separating the variables. So you have to show this step right here where you have y's on one side, x's on one side. So you get 1 point for that always. You got 2 points, so 1 for each antiderivative. You got 1 point for remembering your plus c, which remember I forgot, so I would have messed up. Uses the initial condition, so actually finding the plus c, and then solving for y. So those are the different points. Now here's what I want you guys to notice. You get 0 out of 6 if you don't separate your variables. So if you do everything right, but you do not do this step right here, you get no points because they're picky. So you have to separate your variables. Okay, and then it says if you did not have a plus c, you get 3 out of 6 points. So in my hurry, I would have gotten 3 out of 6 points. I probably would have picked it up later. I probably would have realized it, but you see what I'm saying? And then you just get 1 point for the domain. So it's not a big deal if you forget the domain. You're only missing 1 point, but that could be the 1 point that's the difference between a 5 and a 4, right? So make sure you know the domain. Okay, makes sense? So on your homework, the only ones that you guys didn't know how to integrate were the ones that look like this. So you had like 1 over y minus 1 that you had to integrate. So how would you do that? Natural log of absolute value of y minus 1. Right. What if it had been 2y minus 1? So it'd be natural log of the 2y minus 1 in absolute values. But think about when you take the derivative of that, you'd have another 2 out front, right? So if you take the antiderivative, you need a 1/2 out front. Does that make sense? Because going from this step, if you took the derivative, you'd need to multiply by 2 at the end. So you need a 1/2 to cancel it. Yeah, Victoria?
With the domain, like, how would you know if you had a continuous domain?
Basically, it's with natural log problems because natural log, even though you use the absolute value, like you have natural log of absolute value of x, that means that any negative number you put in will be okay, even though normally we can't take the natural log of negative numbers, but it's the natural log of a positive because we have the absolute values. So the only place that you would get an error if you put it in your calculator would be if you had natural log of 0. That's undefined. We don't know what natural log of 0 is. Okay, so 0, at x equals 0, there's like a vertical line that you're not going to cross. Okay, so you can't, since you can't cross it, it's not a continuous domain. Makes sense?
And if you like don't have a natural log, you just a regular.
Okay, what are other things that you would not have a continuous domain for? Maybe like a square root, right? So square root, maybe things are only defined on like the right side or the left side, depending on what's under the square root. Like if I just had square root of x, you would say x is greater than or equal to 0, right? Or like 1 over x, yep, so denominators. So look for denominators, square roots, natural logs. Okay? All right.
Do you have to get rid of the absolute value plus or minus?
You don't have to, but it's kind of weird. Like if you have absolute value on both sides, you shouldn't have that because you're trying to solve for y. So I usually just get rid of both of them in one step if there's 2 absolute values, like we did there. Because it's kind of like both sides would have plus or minus. Like you'd have plus or minus 1 plus y equals plus or minus x. You know, so dividing by plus or minus just still gives you a plus or minus over here. You know what I'm saying? So I just got to do it all in one.